The atmosphere is the layer of gas that surrounds our planet, protects us from harmful radiation, regulates the temperature, and allows us to breathe. The atmosphere is divided into 5 main layers: the troposphere, the stratosphere, mesosphere, and thermosphere, and the exosphere. Each layer has different characteristics and functions, and we're gonna explore the atmospheric layers in this lesson. But first, we need to understand some concept related to the atmosphere. So first, what is the atmospheric pressure? We know that Earth is surrounded by a gaseous layer. We call this layer an atmospheric envelope. So the atmospheric envelope is the gaseous envelope rotating with the Earth around its axis, and it extends about 1,000 kilometers above sea level. And the weight of this air column or the gaseous envelope push on the ground on Earth by a force, we call it atmospheric pressure. So the weight of this envelope affects the Earth's surface and the object on it by a force known as atmospheric pressure. So the atmospheric pressure is the weight of an air column on an area 1 meter square. The measuring unit is called bar or millibar, where the 1 bar equals 1000 millibar. So this is Earth surface area 1 meter square. So if we take 1 meter square and the air above this 1 meter square pushes on the Earth by force called atmospheric pressure. So the atmospheric pressure again is the weight of the air column on an area about 1 meter square. So in sea level, we call the air that pushes on the sea level normal atmospheric pressure, which is the atmospheric pressure at sea level equals 13.25 millibar. So here is the sea level. So the air that pushes on that line, which is sea level, is called normal atmospheric pressure, which is 13.25 millibar. So does the change in the altitude or the height from sea level affect the atmospheric pressure? To understand that, we make this experiment where we form a 3 similar sphere of clay, each one has different color, and put the clay sphere between plastic sheets. So 3 equal sized balls of clay, each one has different color, and each ball is between 2 plastic sheets. With time, we see a change in the shape of the balls, where the change in the lower ball is bigger than the change in the upper ball. So the change in the sphere of lower clay is maximum because the taller column of books mean the increased weight of the books that pushes on the lower ball. But the change in the upper sphere is minimum because there is a lower length of books pushes on the upper ball, so less pressure, less weight on the upper ball. So the change in the shape of clay sphere increases by increasing the number of books, the height or the weight due to the increase on their weight. Similarly, at lower latitude, the air density and air pressure are higher due to the taller air column pushes on the ground, and in higher latitude, the pressure and air density are lower because of shorter air column pushes on the ground. So again, lower latitude has taller air column, mean more mass, more pressure. At higher latitude, shorter air column mean less mass, less pressure. So as we go up, the air column gets shorter, so the weight of the air column decrease and the pressure decrease. So the relation between the altitude and the atmospheric pressure is inverse relation, because as we go up, the pressure decrease. So here is the standard pressure at sea level. As we go up in latitude, the height increase, the pressure gets lower and lower. So actually here in Mount Everest, which is 8-kilometer height, the pressure is about 200 millibar. And note that the 50% of air mass exists in an area above sea level about 3 kilometers, and 90% of air mass exists in an area above sea level up to 16 kilometers. So that is sea level. Let's take this line as 3 kilometers. This line about 16 kilometers. So from sea level to 3 kilometers, there is 50% air mass. From sea level to 16 kilometers, there is a 90% air mass. So what are the instruments we use to measure the atmospheric pressure? First, we have a device called aneroid. And as you see in the aneroid, we have sun, dry, change, rain, and those are weather condition. So we use the aneroid to determine the possible day weather based on the atmospheric pressure. So aneroid help us to determine the weather condition. The altimeter is a device used in the airplane to know the elevation of the airplane based on the atmospheric pressure. Second, we have an atmospheric pressure map. So the atmospheric pressure map is a curved line joint the point of equal pressure. The point of equal pressure are joined by curved line known as isobar. So in the atmospheric pressure map, we connect the point with equal atmospheric pressure by a curved line. We call them isobar. The center of low atmospheric pressure takes letter L. The area of high pressure takes letter H. And the wind move from area of high pressure to area of low pressure. So this is an atmospheric pressure map. Those lines are called isobar. And as you see, all point on this curved line has the same atmospheric pressure. And the area which has high pressure takes letter H. The area of low pressure takes the letter L, and the air moves, or the wind moves from high pressure to low pressure. The atmospheric envelope consists of 4 layers, and they classified according to the change in atmospheric pressure and change in atmospheric temperature. So we have troposphere, stratosphere, mesosphere, thermosphere, and exosphere. First, troposphere, it's the first layer in the atmospheric envelope, and it means disturbed layer. Troposphere means disturbed because all the atmospheric weather happen in the troposphere. and it's the first layer in the atmospheric envelope. It has 13 kilometer thickness. The pressure in this layer keeps decreasing as we go up until it reaches 100 millibar at the top of the troposphere layer. And the troposphere is important because weather phenomena such as rain, wind, cloud takes place in the troposphere layer, and that affect the weather condition and affect the climate, which affect the activity of all living organisms. So why weather phenomena happen in troposphere? Because it contains 75% of air mass. Second, troposphere is important because it organizes the Earth temperature, and that's because it contains 99% of atmospheric water vapor. And the air in the troposphere move in vertical motion as the hot air move upward and the cold air move downward. And the temperature in the troposphere layer decreases as we go up by 6.5 degrees Celsius for each 1 kilometer height until it reaches negative 60 at the top of troposphere. So we can calculate the amount of change in temperature using the following relation. The amount of change in temperature equal the height above sea level multiply 6.5. And we can calculate the temperature at the top of mountain or its foot by the following relation. So the temperature at top of the mountain equal the temperature at the foot minus the change in temperature. And the temperature at foot of the mountain equal the temperature at top of the mountain plus the change in the temperature. So if the temperature at the foot of Everest mountain equal 20.6 degrees Celsius, find the temperature at its top, knowing that the Everest Mount is 8,862 meters above sea level. So we say the change. First, we get the change of temperature equal the height per kilometer multiply 6.5. So here we have the height by meter. So we have to change meter to kilometer. So height in kilometer equal 8,862 over 1,000. Well, 8.862 kilometers. So the change in temperature equal the height by kilometer, 8.862 multiply 6.5 equal 57.6 degrees Celsius. So the temperature are at top of the mountain, temperature at top equal the temperature at foot minus the change equal 20.6 minus 57.6 equal minus 37 degrees Celsius. In the opposite figure, calculate the temperature at point A, the vertical amount from C to B. Knowing that temperature at point B is -5, temperature at point C 27. So the temperature at point A, temperature at foot, equal temperature at top plus the change in temperature. So the change in temperature equal the height multiply 6.5. So the change will equal 4 kilometer multiplied by 6.5 equal 26 degree Celsius. So temperature at point A equal minus 5 plus 26 equal 21 degree Celsius. The distance between C and B mean the height. So the height equal the change in temperature divided by 6.5. So the change in temperature equal temperature at point C 27 minus 5 degree Celsius equal 32 degree Celsius. So the height equal 32 divided by 6.5 equal 4.92 kilometers. Second layer is stratosphere, and stratosphere it's the second layer of the atmospheric envelope. It has 37 kilometer thickness. The pressure in the stratosphere keeps decreasing as we go up until it reaches 1 millibar at its top. The air in the stratosphere move horizontal, so the lower part doesn't contain cloud or weather disturbance, and the air move in horizontal motion. And that's why pilots prefer to fly with planes in this layer. So the pilot prefer to fly in the stratosphere layer because there is no disturbance and the air move horizontal. The temperature at the lowest part of the stratosphere is minus 60 degrees Celsius, and it increases gradually until it reaches 0 degrees Celsius. So why the temperature increase in the stratosphere? This is due to the absorption of ultraviolet rays by ozone layer. So the temperature increase in stratosphere layer because stratosphere has the ozone layer which absorb the ultraviolet radiation, causing increase in temperature. So why stratosphere is important? Because it has the ozone gas forming the ozone layer which extend from 20 to 40 kilometer height. So the stratosphere, or the part of stratosphere that has the ozone layer, called ionosphere, meaning the ozonic atmospheric envelope. Third layer is mesosphere, and meso means middle, so the mesosphere means middle layer, and it has 35 kilometer thickness and is the third layer of the atmospheric envelope. The pressure again in the mesosphere keep decreasing as we go up until it reach 100th millibar, and the temperature in this layer decrease as we go up until it reach minus 90 degrees Celsius. So the mesosphere considered the coldest layer. And the mesosphere is important because it protects the planet Earth from celestial rocky masses that enter the atmospheric envelope, where some of them burn completely because their friction with air, forming luminous meteors. So when a celestial rocky masses invade the Earth atmosphere, their friction with air in the mesosphere layer and their friction with the air molecule burn them completely, forming the luminous meteors. And the mesosphere layer is much vacuumed. We call it highly rarefied because it contains a limited amount of helium and hydrogen. So the mesosphere layer has only limited amount of helium and hydrogen gas only. The fourth and final layer is thermospheres, called thermal layer because it's the hottest layer in the atmospheric envelope and is the fourth layer in the atmospheric envelope, and it has a thickness of 590 kilometers. Temperature in this layer keep increasing until it reaches 1200 degrees Celsius. And the upper part of the thermosphere layer is called ionosphere. Why it's called ionosphere? Because it contains charged ion. So the ionosphere is the layer that contains charged ions, and it exists in the upper part of the thermosphere up to 700 kilometers above sea level. So why it's important? Because it helps in communication and broadcasting, because the ionosphere layer acts as a mirror, reflect the radio waves transmitted by radio station and communication centers. And the ionosphere is surrounded by the magnetic field of Earth, two magnetic belts called Van Allen belt, in honoring to the scientists who discovered them. And the Van Allen belt act as a shield that protect Earth from the cosmic rays as they deflect the cosmic rays that coming from the sun toward the Earth. So these belts play an important role in scattering of harmful charged cosmic radiation from Earth, which causes the appearance of aurora phenomena. So the Van Allen belt deflect the harmful cosmic rays coming from the sun, and as they deflect them away from Earth, they cause a phenomena called aurora. So here we have the sun, cosmic rays deflected by the magnetic field or Van Allen belt and causing the aurora phenomena.
What is an aurora? An aurora looks like a beautiful display of lights in the sky. These are some auroras that were spotted in the sky over central Alaska. We can also see auroras from space. This is what an aurora looks like from the International Space Station. The name of an aurora changes depending on its location. If you're in the northern hemisphere, it is called aurora borealis, or northern lights. And if you're in the southern hemisphere, then it is called aurora australis, or southern lights. So, what causes these beautiful displays of lights anyway? The sun. That's right. Even though auroras are best seen at night, these colorful displays are caused by our ever-changing sun. How exactly does it work? Well, the sun is constantly sending heat and light to Earth. It also sends other kinds of energy in small electrified particles too. This is called the solar wind. Earth has a magnetic field, which protects us from most solar winds, but it also traps some of the electrified particles in the space around Earth. The sun does not always send the same amount of energy. Sometimes the sun has huge outbursts and blasts more stuff into space than the usual solar wind. These events are called solar storms. During one kind of solar storm, called a coronal mass ejection, the sun burps a massive bubble of gas that pops and sends particles and energy zooming through space. When a solar storm reaches Earth, it dances with our magnetic field, and some of the energy and particles that zip around the magnetic field dive into our atmosphere near the north and south poles. The particles then bump into gases in our atmosphere. These interactions result in displays of light in the sky, auroras. When the particles bump into oxygen in our atmosphere, the reaction makes green and red light. When the particles bump into nitrogen in our atmosphere, it makes blue and purple light. Earth is not the only planet with auroras. If a planet has an atmosphere and a magnetic field, it probably has auroras. For example, NASA spacecraft have captured amazing auroras on Jupiter and Saturn. Learn more about our planet and our solar system at NASA Space Place.
The aurora is a brightly colored light curtains seen at both poles. If it's in the north, we call it borealis, and in south pole, we call it australis. And this is some example of the aurora. Finally, the exosphere. The exosphere is the region in which the atmospheric envelope is inserted in outer space, and the satellite will launch float in the exosphere around the Earth, which we use in TV programs and monitoring the weather condition. And between each two successive layers in the atmospheric envelope, there is a small layer at which the change in temperature and the pressure stop. So we call them bows. And we take the name of the pre-layer. So the tropopause is the region between troposphere and stratosphere. Stratopause, the region between stratosphere and mesosphere. The mesopause, region between mesosphere and thermosphere. And in the layer of stratopause or tropopause or mesopause, the change in the temperature and pressure stops.